Okay guys, today is a review day. That means next class period there will be a test. Now this test is going to cover both Chapter 0 and Chapter 1. You should have in front of you the Chapter 1 review in class. There are about 28 questions on this. What's going to happen is I'm going to give you a chance to do the problem, then we're going to go over it together. So there's going to be a lot of pausing on these videos. So first of all, on 1 through 4, it says how many terms are in each expression. So pause the video, complete this problem. Hopefully you remembered that terms are separated by addition signs, subtraction signs, and equal signs. And so since you see none of those in this problem, there's only one term, and it is just 2x. Number 2, pause the video, complete this problem. We see one addition sign which separates two separate terms. So there are two terms on number 2, 7x squared and 3x. Number 3, pause the video. There again are no addition signs, no subtraction signs, and no equal signs. So that means there's only one term. Even though there are multiple variables, it is just one term. Number 4, pause the video, answer the question. Hopefully you saw here that there are 3 terms, 13, 2x, and 7x squared. All right, next on number 5 through 9, it says what types of numbers does the following symbols represent? So the double-lined capital R, we have the double-lined capital Q, the double-lined capital Z greater than or equal to 0, and the double-lined capital N. What I would like you to do is pause the video and write the names of each type of numbers for all of these, and then we can go over all of them together. Okay, hopefully number 5, the double-lined capital R, you got as real numbers. 6, the double-lined capital Q was rational numbers. 7, the double-lined capital Z was integers. Whoa, if I could spell. Integers. 8, the double-lined capital Z greater than or equal to 0 were whole numbers. And number 9, the double-lined capital N, were natural numbers. Now, this was something we did on the second day of school. It has been very popular on your homework, so I would expect to see it again. Number 10 says, give an example of a whole number that is not a natural number. So if you guys remember back to that Venn diagram that we had, it started with the natural numbers, and then it had the whole numbers, and then it had the integers, and then it had the rational numbers and the irrational numbers, and altogether those were the real numbers. So I need an example of a whole number that is not a natural number, and there's only one option there, and that is 0. Number 11, give an example of an integer that is not a whole number. So an integer that is not a whole number. And our only options there would be any kind of negative number. So -1 would work, -5, -100. A negative number that's not a fraction, not a decimal, is an integer that is not a whole number. Number 12, give an example of a rational number that is not an integer. So a rational number, or these numbers out here, and remember that was any number that could be written as a fraction, where both the numerator and denominator were integers, and the denominator was not 0. So you can come out and you could say 1/4 would be an example. Or you could say 0.5. Or that was a terminating decimal, or a repeating decimal, so 0.3 repeating. All of those were rational numbers that are not integers. On number 13, write a verbal expression for each algebraic expression. So I need you to pause the video and write a verbal expression for number 13. All right, hopefully I put 9 times a squared. Some of you might have put 9 times a to the 2nd power. That's fine. What is really important is we have to have that word times in between 9 and a. You have to tell me what's going on in between them, because I'm not squaring the 9 and the a, I'm just squaring the a. Number 14, pause the video, write your expression. I put 7 times x cubed minus 4. You could have also put 7 times x to the third minus 4, or 7 times x cubed, or excuse me, the difference between 7 times x cubed and 4. There are several different options. Again, make sure you have the word times in between 7 and x. Number 15, pause the video. Hopefully you got 4 times the quantity of 2 times x plus 1. So remember, when you see these parentheses, it is so important that you represent it by times the quantity of. It is not just parentheses. You have to have that phrase in there, times the quantity of 2 times x plus 1, or the sum of 2 times x and 1. Number 16, pause the video, write down an algebraic expression. So the sum of a number and 10, sum means plus. We don't know what that number is, so I'm going to call it a variable. So I want to add that number and 10, and we get x plus 10. 17, pause the video, write down your expression. All right, remember, less than means subtraction, but since it has less than, there were 2 phrases, less than and more than, means we need to go backwards. So instead of 15 minus k, we need to go the other way around and say this is k minus 15. 18, pause the video. More than is the other phrase that means we have to work backwards, so we're going to be adding, but this needs to come first. So twice m, this was important, was actually 2 times m plus 6. Number 19, pause the video. And you should have gotten 2 times y squared. Product means multiplication, second power of y. On number 20, I would like you to pause the video and complete both sides of this proof, and then come back and we will go through step by step together. Alright, so first step, remember the justification is always given. We need to make sure that we number each step and that they're nice and in line. The next thing we needed to do is see where we had to go next according to the order of operations. So hopefully you simplified 9 divided by 3 to get 24 times 1 minus 8 plus 5 times the quantity of 3 minus 3. And that, to get from step 1 to step 2, is the substitution property. You must spell out the word substitution. Next, according to the order of operations, we need to take 3 minus 3, and that's going to give us 0, so 24 times 1 minus 8 plus 5 times 0, and that should be the additive inverse. You can abbreviate the word add, the additive inverse. Then we want to take 24 times 1 to get 24 minus 8 plus 5 times 0. And that would be the multiplicative identity because we multiplied something by 1 to get itself. Then I want to take 5 times 0 in order to get 24 minus 8 plus 0, and that would be the multiplicative property of 0. Next we'll take 24 minus 8, which gives us 16 by the substitution property. And then 16 plus 0 gives me 16 again, and that would be the additive identity. On the test, I will give you your properties. Now, I will not give you which ones you're going to use, but I will give you a box for you to choose from. On number 21, it says simplify the following expressions by combining like terms. Go ahead and pause the video, get that done. Hopefully you saw that these two combine and you get 5x plus 6. 22, pause the video, combine like terms. Now just a reminder, to combine like terms, you must have the exact same variable raised to the exact same exponent. So I would start with 2xy, which cannot simplify with anything. I have a 3x and a negative 4x, so minus 1x, and left with plus 5y. 23, pause the video. Here, first we need to distribute, so 3 times x squared is 3x squared. 3 times negative 2x is negative 6x, and bring down that 5x squared. Then we can combine like terms, so 3x squared and 5x squared is 8x squared, and I'm left with minus 6x. Next, on number 24, identify the independent and dependent variables for each relation, then describe what's happening in each graph. So on 24, it says the graph represents the height of a baseball after it is hit. The independent variable and dependent variable. Please pause the video and identify both of those. Alright, hopefully the independent variable you got time and the dependent you got height. Now what we need to do is describe what's going on in the graph, and remember I need you to tell me exactly what's going on as if you were there. Please don't use mathematical terms. I want you to tell me what the graph is describing. So pause the video and give it your shot. Okay, now this is actually open to interpretation, but here's kind of what I'm looking for problems like this on the test. I started by saying the baseball is hit some height above the ground. We don't know how tall or how high it is off the ground, but I know that it wasn't on the ground when it was hit. So the baseball is hit some height above the ground. Then it rises higher before it falls back to the ground. That's all I'm looking for. Be descriptive. Describe what's happening in the graph. Number 25, is the mapping a function? Explain. Pause the video. And the answer is no, because the element -2 in the domain maps to more than one element in the range. So it's got 2 arrows coming from it, so it is not a function. 26, pause the video and get that one done. Clearly this one is a function. Sorry guys. This is a function, and the description is very specific. Every element in the domain maps to exactly one element in the range. So it is a function. Now on number 27, please make a mapping on your own. That is a function. Now all of these could be different because you can use however many or however few numbers you want. For me, I just was very simple. And I had 2 domain, 2 range, and I made sure that each domain only had 1 arrow coming off of it. You could have also said that, well, I only have 1 range, and as long as 1 arrow was coming off of each domain, that works. Now on 28, make a mapping that is not a function. What's important on this one is that in your domain, you just have to have 2 arrows coming out of 1 number. So as long as you have 1 number in the domain that has 2 arrows coming off of it, you have something that is not a function. All right, guys, test next time. If you have any questions, please make sure you come ask. I would love to help you.